Today we are here with a gorgeous 2011 BMW X5, and this car has an interesting problem. You cannot get the oil level after doing a service. So let me show you that here. We're going to put the key on. So the key is on, and there are no error codes on the dash. So let's go here to the display, wait for it to boot up, and we're going to select the menu, and we're going to go to vehicle information, select that, vehicle status, and right there we have the oil level. Now seemingly right now it's showing engine oil level below minimum, add 1 liter, but you're supposed to actually check this when the engine is running. So let's start the engine. It's a diesel, by the way, so it's going to measure the oil level. It's supposed to take about 3 minutes and then give you the result. And there is what you get. Measurement inactive, have this checked. So this garage has replaced the oil level gauge sensor twice, and it does exactly the same thing. And that's when they've called me to do a comprehensive diagnosis on it. Now I did ask them to give me the original sensor, but they said that they threw the first 2 that they put in, and the third one is what we have here. So I don't know if it's the correct part number. I really hope this is not a part number abuse issue. That seems to be a very common thread in this country, but we'll see. Now this is a Euro car, and I will tell you, for Euro cars, especially BMW, do not waste your time using an aftermarket scan tool on BMW. You're going to chase your tail and you're going to be frustrated. Often you will get codes which are correct, but the text designation is going to be wrong. Launch does this a lot. I do not advise you to use an aftermarket scan tool. The only aftermarket scan tool that I have seen which works very well on BMW is the Autologic scan tool. But that scan tool is very expensive and has very limited supply. You can't get it very easily. It's only sold, I think, in Europe. So we are going to use ISTA. So my laptop is ready. Let me fire up ISTA, and then we are going to proceed with the diagnosis. All right, we are in ISTA, and a lot of people have issues using ISTA. I'm using it with the K+ DCAN cable, and I have found that if I have my cable connected and then I start ISTA, it will never connect. So what I do is start up ISTA, let it load this screen, and then plug in my K+ DCAN cable right there. And now it has recognized the cable, and now we can begin. So let's go here to vehicle information, operations, and we're going to read out vehicle data. Let's put the key on. Actually, we're going to run the engine. I don't want to get stuck here with a bad battery. We're going to do complete identification. Right, the test is finished, and there are a number of videos that show how to use ISTA online, but all of them kind of fall short in different ways. I've not really found someone who has delved into how to use this in an advanced way. There's one guy who did pretty good job, and I think he has done the best, and I recommend watching his video. But I think I will do one where I will go through this and give you an idea of how to troubleshoot properly with Easter. Navigating your way around Easter isn't intuitive. This software right here, Easter, is only second to Odys when it comes to the usability of it. It doesn't have a very good user-friendly interface, so it takes some getting used to. If you want to know which control units you are looking at, you just hover and it'll show you. We are interested in the DDE, and this is the diesel fuel electronics. Now, there's something with Easter that nobody ever talks about, and it is a pain. If you want to see your fault codes, you move from this control unit tree and you come down here, display fault memory. But when you do that, look at this. It displays all the fault codes and you have no idea which one belongs to which module. What is the DDE? What is the other modules? I am not interested in other modules. I just want to see the DDE faults. And if you look at this menu, there is nowhere where it filters per module. If you come here, you may think that this will be filter fault memory, maybe for module, but if you hit that, it brings this. This is garbage. I do not want. Why would you ever want to filter your codes by kilometer? This is nonsense. I never want to do this. I want a view where I can see which codes belong to which module. What I have found is there's a workaround. If you go to the vehicle information tab, we have the control unit tree we left, but there is an operations report. So we click that, and in this operations report, if you come down here, you are going to see fault memory, and then it'll list it by module. But then it doesn't give you the module name. It gives you the module ID, not even ID. It actually gives you the control module variation. So if you want to know which one you're looking at, we go back to the control unit tree and we are interested in the DDE, or whichever one you are interested in. Today I'm interested in the DDE. Click there and you'll see here, now if I move my mouse it'll disappear, so I'll just leave it like this. You'll see the variant. The control module variant is D73N57DO. So now that we know our variant, we come here back to the operations report and we look for the fault codes. Scroll down here and here are our codes, and this is the variant D73N57DO. So this here, these are the codes that belong to the engine control module, and that's the only ones I'm interested in. So let's come here. BSD message alternator missing, BSD message intelligent battery sensor missing, LIN bus communication fault, BSD data bus communication fault, no message, set point torque, drive off assistant, receiver DDE, transmitter DSC. This is the gearbox, I think. So we seem to have a network issue in the engine. Now, is that related to our sensor? Maybe, maybe not. We don't know. So what we're going to do is keep this in mind, because I'm not going to do a diagnosis unless I am told to do it. If this is part of our problem, then we're going to tackle it. So what we're going to do is come here to vehicle management, and we are going to come here to text search. And first I'm going to filter, select nothing, and what I want to do is get my wiring diagram, functional description, installation location, pin assignment. Okay, I think that will do for now. Then we accept, and then I'm going to search for oil sensor. All right, that's all we have. And I'm going to put off the engine. And interesting, we don't have a wiring diagram, but for now, let's go to the functional description of the oil condition sensor. Is that it? Oh, let's see that. Oil condition sensor. The oil condition sensor increases the function range of the thermal oil level sensor. Okay. The oil condition sensor measures the following variables: engine oil temperature, oil level, that's our guy, engine oil quality. The engine control system evaluates these measurements. With the oil condition sensor, electrical properties of the engine oil are also determined. These properties alter the engine oil and shows signs of deterioration and aging. In layman's language, what they're saying here is the oil grabs the impurities of the motor when it's running, and the impurities are metal parts that come out. So the oil becomes more and more conductive because it gets more and more metallic particles inside. Those metallic particles increase the conductivity, and there is a set point where the conductivity reaches and it shows that your quality has deteriorated. So I think you're going to have a range. So the brief component description: the following components are described. Oil condition sensor. The oil condition sensor is attached to the oil sump and is accessible from below. All new engine types, there is no longer a dipstick. These engines have an electronic oil level check. That is why these guys are concerned, because they can no longer check their oil level clearly. So you've got this thing, and that's the sensor. Got the oil sump there. Temperature sensor. 3-pin plug connection. And then number 2 here, we have got the oil condition sensor. So it has a temperature sensor integrated into it, but the whole thing is an oil sensor. Now, I'm interested. You see this? 3-pin plug. How do you have only 3 pins, but this is supposed to give you all this data? Engine oil temperature, oil level, engine oil quality. Well, if you know anything about sensors, you know something that has 3 pins and it gives multiple outputs, the only logical explanation is that it has a LIN bus output. And yeah, that's exactly what we see here. The oil condition sensor is connected via a bit serial data interface to the engine control system. Why do you just call it a LIN bus? BMW? The voltage supply is dependent on the engine version, e.g. via terminal 87, terminal 15, or terminal 15N. The following graphic shows, by way of example, the voltage supply via terminal 87. So these terminals are either key on or key engine running, etc. So we've got our DME or DDE. In our case, it's DDE because it's the diesel engine. And then we have one data line, and then that data line is connected to our sensor over here. So we have the engine control unit, oil condition sensor, and then bit serial data interface, which is a LIN bus, and then we've got our terminal 87. Basically, we need a power supply, we need a ground, and we have a data line on that sensor. The rest of this describes exactly how the sensor works. I don't need this information. We already have what we came here for. We know we are looking for a power, a ground, and a data output. So we can go to, we don't even need to go to the wiring diagram. We've already been given our pin assignments. So I tell you what, let's go down to the sensor location, and then we are going to probe the 3 pins. And I want to see a ground, a power, and a data line coming out of it. Let's go to the sensor. All right, here we are under the vehicle, and that is our oil level sensor, and that is some aftermarket sensor. I do not trust aftermarket sensors, but is that really our problem? Maybe, maybe not. I'm not going to make an issue out of it unless I test it. But it's never a good idea to use aftermarket sensors on systems like these. We have our 3 wires right here. There they are. And let's put the Pico here, and we're going to see what we get in terms of signals. All right, we have probed our connector. 3 channels, channel 1, 2, and 3. I don't know which wires those are. Don't care for now. All I know is I need to see a 12-volt feed, a ground, and a LIN bus. And now that we are probed, let's go to our scope and see what we have on this line. All right, we are ready to take this capture. The Pico is running, and right now we have 0 volts on all the lines because our DDE is completely asleep. First thing I want to do is put the key on right here. And we have some activity, but this activity is fishy. Let me just pause that. And I want us to look at this real quick. So right now, we are showing that we are trying to read the engine oil level, but I can tell you something. This isn't a genuine reading. Let's go to the scope here real quick, and I'm going to zoom in here. This is not a valid LIN bus. All right. So we do have pulsing there. That's 10 volts, starting from 700 millivolts. The range is valid, but the data is invalid. On our green channel, we have 12.04 volts. That's our power. And on our red channel, what do we have? We have 3.5 millivolts. That's a good ground. So we have a good ground, we have a good power, but this LIN bus is just not, it's not a LIN bus. I don't know what this is. So something is wrong. Is this sensor not, I don't know. Something is wrong here. So let's start the engine. Oh, goodness sake. Guys, look at that. We don't even have to go any further. That is why we have this going on here. It can't measure anything. So let me pause that and let's look at this again. So this LIN bus is shorted to power. There's something on this line that's not good. Now, I can't help but think our engine was complaining about other things on the LIN bus. Is this the only thing on the LIN bus? I don't think so. I suspect we have a LIN bus problem and it's affecting several modules. There is something here that is crapping on the network and is just spitting 14 volts. Something is shorted here. But for now, let me play this again. I tell you what we're going to do. Since our engine is running, let's go to that sensor and we're going to disconnect it. And then we're going to see what happens to our LIN bus activity when that sensor is disconnected. That's an aftermarket sensor. I do not trust aftermarket sensors. It could be that that sensor is bad and when they installed it, they installed this problem in this car. So let's go and unplug that sensor and then we are going to take this capture again. All right, we've disconnected our connector and we're still probed in it. But there's something else I've noticed. You see this? This is oil and it's coming from within this connector, which means this sensor is leaking. Even though this test shows that this sensor is not the issue, this sensor must be replaced. The reason is this oil is going to come out of here and it's going to wick up this harness and it's eventually going to find its way to the engine control module and it's going to damage the engine control module. Aftermarket bullcrap. This must be replaced with the OEM sensor. Let's go back to the Pico. All right, our connector is disconnected. Let's put the key on. And you can see we still have the same malfunction on that line. Let's pause it here. And let's look at that line. All right, we still have the same malfunction there. So our oil level sensor is not the problem, but again, we still need to replace that sensor because it's wicking oil out and up into that harness. So let's go now to the wiring diagram, and I want to see what's connected to this LIN bus. One of the things that I was complaining was the alternator. So what I'm going to do is to look for the alternator in the wiring diagram, and then I'm going to see what is connected with the alternator on the LIN bus, and I'm sure we're going to find this sensor there as well. All right, we're back in ISTA, and I want to close this out. Now, when you see LIN activity on a line, I want to know what else is on that line. A LIN bus can have several modules. So do we have only the engine control module and that? I highly doubt, and I'll tell you why. Let's go back here to vehicle information. Look at our codes. BSD message alternator is missing. BSD message intelligent battery sensor missing. LIN bus communication fault. BSD data bus communication fault. No message set point drive off assistant receiver DDE transmitter is DSC. That is the transmission. These are all LIN bus messages. I'm not going to ignore this. I think all these are in the same bus. Let's go back to our vehicle management and our text search here. I saw a BSD that showed up when I was searching for that oil level sensor. So I'm going to search for oil sensor again. Here it is. You see this? BSD, bit serial data interface. And this is a functional description. Why don't we go in there and read what it says? The bit serial data interface is a single wire data bus with a data transfer rate of 1.2 kilobits per second. That's a LIN bus. The following components are connected across the bit serial data interface. I'm just going to call it a LIN bus from now on. The following components are connected across the LIN interface with the DME or DDE control unit. Alternator, intelligent battery sensor, preheating control unit for engines before the introduction of engines N47 and N57. I think we are in 57. I'm not so sure. Engine coolant pump. Oil condition sensor. You see? So we have these items here that are on the same LIN bus. So one of these items is bad and is crapping on the network. So the following data is interchange between, I'm not interested in that. Diagnosis, a DME or DDE monitors the communication across the LIN bus to the connected components. This means that the line faults are also detected, which has flagged the fault codes that we have. The connected components have their own diagnosis functionality and monitor the following. Okay, the executed functions are monitored for faults, the internal faults of the components. My main interest is here. Now I'll tell you what, when a LIN bus goes bust, you need to find the component that is in the worst operating conditions. Out of all these components here, which one do you think is in the harshest operating conditions? And remember, the operating conditions for a control module that are really harsh are heat and vibration. This guy, the alternator, is in the harshest conditions. First of all, it vibrates a lot because it's spinning. Because it's spinning, it produces a lot of heat. And also, it's producing northwards of 100 plus volts, which is a very harsh operating condition in terms of voltage. So, bingo, we have got harsh conditions all round. Vibration, heat, high current, high voltage. Let's go to this alternator and disconnect him. And then we are going to look at that LIN bus again. So if I come here to my vehicle management, let me just search for alternator. And this time, I'm only going to search for the wiring diagrams, which is the SPP. So uncheck that, uncheck that. And then let's start our search. And then we have the BSD alternator. And remember, BSD is bit serial data. So let me close that. That's all I need. Get in there. And that's my alternator. So it has a LIN bus here on that violet wire to the engine control module, and then the heavy gauge battery cable that goes there. So it only has two cables, the heavy gauge battery cable and the LIN bus. That LIN bus goes to the control unit, engine control unit, and then there is another LIN bus here that comes out that goes to the battery, intelligent battery sensor. And then we have this. What is this? I think this goes to another LIN bus. Okay. It's not showing me where to go. It's just showing me the location of that. But it doesn't matter. What I need to check is my LIN bus right here. So let's go directly to the alternator, and we're just going to disconnect that alternator wire, the control wire. It should only have one cable on it, one line, a violet line. Let's disconnect it, and then let's go to our Pico and look at our LIN bus and see what happens to our LIN bus. All right, here we are in the engine compartment, and that is our alternator. And I have disconnected the LIN bus line, and that's our violet wire. And remember, we had only two wires, the control line, which is a LIN bus, and the B+ line, which is this one. Let's go back to the scope and see what we have on our LIN bus now. All right, we are back in the vehicle. Pico is running. Let's put the key on. Oh, sweet. Look at our LIN bus. Let's pause that. Now that is a LIN bus. Why do we have different things going on here? Well, it's because the control modules do not pulse down to ground the same way. So this is showing me how many control modules? 1, 2. I'm seeing 2 of them here. Very nice. Now let's come to our display right here, and let's start the engine. Let's watch that display. Oh, very nice. Now we can measure our oil level. All right, this is a fix. Well, not really a fix. We have a bad alternator. We need to change that alternator. And we also need to change the oil level sensor because it's wicking oil out. Sometimes these alternators, you can get the control unit inside, which is the back of the alternator. It comes with the brush assembly. We're going to look in the wiring diagram and see whether we have it. But that is it for this one. On the bonus section, I will show you the part number for the alternator and for the oil level sensor, and whether the alternator has got a control module inside that can be changed. All right, now let's go to ISTA and let's clear those codes, and the only code we should be left with is for the alternator message missing. All right, back in ISTA, let's close this one out here. Let's go to vehicle information, control unit tree, and we go to our DME, select it, and we're going to call up ECU functions. Component triggering, and we're going to delete fault memory. But first, let me put the engine off and put the key on. Key is on. Let's trigger component. It's deleting fault memory. Now it's just hang here. I don't know if it has deleted. So let me close that and let me start vehicle test again. Okay. So let's go to operations report, and then we go to the DTCs. So it didn't delete them, but you can see here is currently present. No, 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 and this one, LIN bus fault, yes. And why is it present? Because we have the alternator disconnected. Now let's go to the control unit tree, and we're going to display fault memory, and we're going to delete fault memory. Yes. I don't know why it did not delete on the other side. Switch off the ignition and remove the key. You're going to wait for the car to go to sleep completely. Let me start the vehicle test again. Alright, it did delete faults. I don't know why it refused to acknowledge that the key was off. Alright, now we only have one fault. Let's display it. LIN bus communication fault. Existent, yes. So, new alternator will repair this car. One final look at the display. I want to show you what the display looks like when you are looking at it before you start the car. It should say that we have sufficient oil to start the engine. It shouldn't give you a level. Okay, let's put the key on. Key is on. And if you look here, it says oil sufficient to start engine, and it should only measure when engine is running. So that is good. And then the dash here is nice and clean. And you should also get a battery symbol, which we were not getting, to just warn us that we are running on battery and we are going to deplete it if you continue running the engine. So this car is fixed. So now, one more time, if we start, it'll now measure the oil, and it'll tell us that the oil is sufficient. So now it's measuring. And there we go. Engine oil level is okay. So that's a sigh of relief. The engine has been running with good oil level all this time, so no damages done. That's it for this one. 2011 BMW X5 with a bad LIN bus, and the LIN bus was affected by a bad alternator. New alternator and new oil level sensor will fix this car. That's it for this one. And for the bonus section, I'm going to show you the part numbers that we are dealing with and how to get them. Otherwise, another one for the books. Until next time. All right, let's look at the cost of these two parts. PartsLink 24 is a very nice resource for getting these EPCs right here. I use it mostly for BMW and Volvo. It is a paid service, it's not free, and you get all these. Land Rover is also very good here because Land Rover EPC is more expensive to get it from Land Rover than to get it from here. It's about 24 euros per month. I only pay for the months that I need it because I don't need it every month. Okay, so let's go to the BMW parts catalog. And this is our vehicle. Engine, oil pan, oil level indicator. And that's our sensor here. Your part number is 12617607909. This one is the OEM sensor, and I recommend you only use OEM sensors for Euro cars. Aftermarket, you're going to be doing this work 3-4 times, trust me. Okay, that is your oil level sensor. Let's go back to the engine here, and let's go to engine electrical system, alternator. And it says here, please determine the installed alternator independently or by means of diagnosis. I checked from at ISTA, and we have the 230 ampere voltage regulator. So this is my regulator here. Number 2, you can see you can buy the voltage regulator alone. And that's your part number 12317603776, made by Valio. So you don't have to buy the whole alternator. This comes as the regulator and the brush assembly integrated. Do not buy aftermarket. You are going to have problems. So let's look at the approximate pricings. And the oil level sensor comes in at 168.2 euro, and the regulator comes in at 107.7 euro. The regulator is cheaper than, yeah, interesting. Anyway, that's it. So these ones are unavailable in Kenya. I'll just give the garage to import. If they choose to cheap out, that's their problem. Not my monkey, not my forest. My job is to just diagnose and to tell them what they choose to do is their business. As for me, I've done my business, and I'll see you next time.